Bismillahirrahmanirrahim. Today I'm going to implement the code for a single linked list. First, we need to know what is a linked list and why we use this in our coding. So, a linked list is a data structure in which we use to store our data, any type of data. It is basically a list, so it can store any string or integer type of data. So, singly linked list. First, I'll write here singly, wait, singly linked list is basically the unidirectional list. What does this mean? Unidirectional list. Unidirectional list means that it's a list that you can only traverse in one direction from head node to tail node. So in this list, you can only iterate through the through one direction, which is from forward to backward. You cannot traverse back, like from in a reverse direction. You can only traverse in one direction from head node to tail node. So basically the syntax of a singly linked list is that in linked list, the syntax is basically that you must always have the node class. So node class define the simple node. For example, in tree there are nodes, so node class will define the simple node in which each node has two attributes. These are the data and the next attribute. So data holds the data of a node, while next points to the next in a linked list, which is initially set to none. So in next there will be the address of a next node. So I'll start from class node. I'll make a method def for initializing the linked list, which contains self comma data. Self dot next is equals to none. Basically it will say that the linked list is empty, or the linked list has only one node. So initially we don't have the address of a next node. So this def method is used for initializing the linked list. So now I'll make another class singly linked list. So I'll make another method for creating the singly linked list. This method was used to create a node. This method was used to initialize the singly linked list. We basically use the head representation or head instance of a tail for better representation of a singly linked list. So we will say that self dot head is equals to none. It means that the head we use head instead of a tail for better representation of singly linked list. So here we said we initialized inside the singly linked list, we initialized with a head attribute which representing the first node of a singly linked list, and it is set to none. It means that the head contains nothing, so basically the list is empty. So head is the first node. Now we are making the another method, which is def. Now this method append method is used to add a new node with the given data to the end of a list. It will add a new node to the list. So we say that node is equals to node. It will contain the node data, and we are saying that if self dot head is none, then what you have to do is self dot head is equals to node, otherwise self dot head. Now what we are saying that we are just saying that it creates a new node using a node class. So we are saying that initially it is head contain nothing, so we will create a new node. Self.head is equals to node. We are creating a new node using the node class, and otherwise use the current head value. So we are saying that the current node will be the head of a node. Now we are saying that while current dot next, we have to iterate till there is a current node dot next. So current is equals to current dot next. So it will iterate until we do not reach the next node of a next of a current node next. So it will the next of a current node contain the address of a next node. So current dot next is equals to node. So we are saying that we have to iterate until till this current dot next. We are saying that current is equals to current dot next. We are saying the current node has the next node, which is current dot next will be the next node, another node. So we are iterating through each node which contains the next. So next will in next attribute or in next portion, we say that it points to the next in the linked list. So next means the address of a next node.